And welcome back. So today, sorry for the delay, just a little bit later. Oops, and let me just stabilize the camera a bit. Yep. So today we're just gonna look at continuing where we left off last week. So last week was a little bit different, and because it was pre-recorded, but today we are live again, albeit with a bit of a delay, and we'll just get right to it. So let's see, let's go sardine sources, just check. Sorry. All right, there we are. Okay, so let's see where we were. So so last time we've been looking for now several sessions at what happens to the KOs and whether we can find KOs that are good markers, and so we first used the UniRef as a reference for what KO size, or for the size of a particular ORF that codes for that KO, or that codes for a gene such that the gene gets grouped into that KO. And we first used UniRef as a reference for what should be the let's call it the normal KO, the normal ORF size. And last couple of weeks we tried using the GMGC, so version 1, using the complete genes, as that we figured that would be a better reference. But actually, after a fair amount of effort of running things, it wasn't clear that was indeed a better reference. But still, it's conceptually cleaner because those should only be prokaryotic genes, number one, as opposed to UniRef, which had a lot of eukaryotic stuff. We only had complete genes, and they were also supposedly from metagenomics, which should be a better fit to the data that we have, as opposed to UniRef, which is very, very biased by database biases, what we as humans have found interesting to culture. So we spent last time started to also do a bit of cleanup in the code. So the code, so we did a bit of cleanup, still not, but still this length by KO file, it's quite long, and sort of not great code. So let's today maybe just spend a little bit of time also cleaning this up, consolidating what we've done in the past, and just generally speaking, making it nicer. Okay, so there it is. Okay, so let's just okay, so this is what we had in the past. Again, loading the outputs from Diamond that we run just based on so that we don't run Diamond, so CheckM2 runs Diamond. So ideally, or one nice outcome for an eventual tool would be that this can post-process what CheckM2 does, and in which case for the users, it would be very convenient, because if they run CheckM2, and then this could be a quick thing that runs and adds to CheckM2's output. So easy one. Yeah, so we've done, so this is what we, all right, okay, so this worked reasonably well, but in this case, all right, so in this case, we only took the easy cases, right, where we had KOs from all of that appear in all of the genomes and appear exactly one time, which is you know, but there, for example, there are KOs that are missed, right? So, for example, this is these are the set of KOs that are missed in the, actually quite a lot. Yep. Okay. So let's get rid of this stuff. Okay. Also, this is sort of kind of awful code anyway. So what we want is okay. Let's just, let's just cleaning this stuff up. Yeah, let's just right, yeah, we're just here, again, just cleaning up this code a little bit, or more than a little bit. But just, right. Oh, okay, yeah, there was some mistake here. Alright, sorry, I need to go fix my new vim. Oh no, I don't. This one? Yeah, sorry, that was Sorry, no, my bad. There. Okay, diamond out. No, this is not one of them. Elements number G. Yeah, so. Just making it a little bit nicer there. Okay, slightly nicer there. Sorry. Okay, slightly nicer. Okay, doing. Let's do this. So we have okay now. All right, let's see. All right, now let's see. So we have wild type there. Join. Yeah, so we want to join on. Yep. Okay, let's say we do it this way. Right. let's do simplify. Okay, we can do something like this, right? Number of mutations, KO, the length. So if we do this, so if we do this, okay. Okay. So, it's simply okay. So let's think about. All right. So. Don't think so. We need some sort of map rows, something like this. Okay, let's do this in this horrible way. Let's do this in this horrible way. Okay. Okay, this is what we had before, but this is much nicer now. This is much nicer because before since we were actually restricting ourselves to the KOs where there was only one hit at every level, which is incredibly which it is kind of faking it or cheating, because in real life we won't know, right? In real life we don't know if we're here or there. We don't know if we're in the wild type situation or if we're in the this is a crappy genome situation. Let's see. Let's redo this other analysis and plot that we had as well. Okay, so this is yep. All right, let's try this. Group by. Okay, let me just see. Okay, this works. No, it's just yeah, we need, wait. Okay, it's looking pretty terrible, but column. Yeah. Yep. Okay. Okay, it's pretty. Okay, now we can view. Okay. All right, we're almost there. We're almost there. Okay, this is correct. Okay, that's the problem. Oh. Okay. Yeah. Okay. Much nicer. Okay, this part here, this is still pretty rubbish. Okay. It's still a bit rubbish here that we're iterating over the data frame like this, but it is what it is. Alright, so I'm just gonna run everything from scratch. So today was mostly consolidation, in the sense of cleaning up the code, but also removing some of there were a couple of little things. So the filtering was not done properly because it had allowed us to do this graph. Let me see if it's found it. Oh, sorry, that's bad. So it had allowed us to do this graph where we trace the same KO, but which was an interesting visualization, and I think helped build a bit of intuition, but it is kind of faking it because, you know, in real life we don't know if we have the wild type. So now this is a little bit cleaner that we don't have. So this is a little bit cleaner. So now so now we just the code's also cleaner, which is nice, but conceptually it's also cleaner to just take all of the KOs, all of the ORs, and independently of where they okay, this wasn't the point, but right there, then it also runs a little bit faster. sort of seeing whether it's worthwhile to optimize that. No, this runs really fast. Everything's nice. Okay. All right, I'm gonna wrap up. Yes. So for this internal code, I'm not gonna extensively add documentation, but a couple of lines describing the function is good. Okay. Just yep. Notes. Okay. Let's see. Clean up. So today was, as I said, was mostly consolidation. There was not, there was not a lot of forward progress scientifically, but we consolidated the codes, easier to understand. It's much simpler to some conceptually. We're loading everything, not doing these funny filterings, and then we are the funny filterings were mostly so that we could do that one plot, which was a cute plot, but that's not. It relied on the fact that we know the answer, right? We know, so that we were comparing the wild type to the mutated version, right? In real life, we don't know what we have. We have a genome, and that's it. Right. So with that, yeah, I think we are done. So. Code. So we optimized also, we replaced a lot of logic that was written in Python with loops by calling Polar's code. There's still one loop. It's okay, it's fast enough, but a lot of it is now just calling Polar's to do the joins rather than relying on Python. So use all. So yeah, so right now we've done actually two things. Well, we've both removed. So we removed KOs that, or we include. So previously we wanted KOs that were only single copy KOs, but they're also present in wild type and mutated versions. So using only single copy ones is actually valid because in principle we know whether we only have a single copy. It was the looking across the variants of the genome that's not valid because in real life we don't have variants of a genome. So here we've done both. It really does simplify things to use everything. So let's keep that for now. And then yeah, looking at the updated plots, I frankly don't really see a difference. So for now I'm gonna keep this. I'm gonna keep this. So, as usual, everything is on GitHub. So I just pushed it. I will update I'll update the mailing list as well, and I will see you next week.